Recording, my OBS not recording. Okay, Bismillahirrahmanirrahim. Okay, today we continue again with our chapter 4, newest topic, which is under operation statement. Okay, so for the course today, okay, the outcome is for you to know the operation statement based on arithmetic operation, operand, operations and operand, and then we have trigonometric functions, and then we have symbolic mathematics and also binary operators. Okay, so then we have you to have some exercise for you to implement operation statements based on numerical knowledge in a program. So this is what we are going to do. So basically, what is operands? Operands is like here in equation we have x and y here is called operands, and then we have operators, and then we have results. So operators is all the symbols here lah, plus minus arithmetic symbol, all of them lah. Okay, so for arithmetic operation, okay, we have a few types of operators here. And we have arithmetic operator, we have comparison operator, we have assignment operators, we have logical operators, we have bitwise operators, and then we have membership operators, and then we have identity operators. So this is what we are going to discuss for today. Okay, let's start with arithmetic operation first. Okay, this is somehow what we have done before, okay, indirectly. So I'm going to focus more on this this week, okay, about the content here. And then we have here for arithmetic operations is addition, subtraction, multiplication, division, modulus, exponent, okay, and then also we have law division here, okay, which we have discussed before, okay. So for arithmetic operation, okay, if you conduct it like this, okay, we have done a few weeks before. Okay, like for example, C equal A plus B. Okay, here if you have print line for the answer is C. Okay, this is minus, this is multiplication, this is division, this is modulus, this is exponential, and this one is for law division. Okay, so next, okay, for this week, okay, we are going to start with more complex things, which is starting with comparison operator. Okay, so for comparison operator here, we have 7 new symbols for you, 6 new symbols for you to recognize here, which is equal, equal, not equal, more, less. Okay, and then here we have more or equal, and then we have less is equal. And all of the answer, okay, is either true or false. Okay, true or false. Okay, 0 or 1. So the answer can be true or it can be false. So if A is equal B, means it's truly equal, then it will be answer true. And then if not equal, it will be answer if it's not equal also, if you correct with the symbol true. If you use, like for example, A is equal 10. Okay, let's just demonstrate to you here. Okay. Oops. Okay, let's just demonstrate to you here. So we have here, okay, let's make one example. A is equal 10, B is equal 15, and let's make 5 first. 5, and then we have, okay, C is equal A equal B. Let's just make it like this. Print A equal B. Okay, so let's see what the answer is. False. Okay, so you see we get the answer here, false. Okay, so 10, A is 10, B is equal 4. Print A is equal B is false. Okay, so let's try again. Okay, if A not equal B, and what is the answer? And you get the answer true. Okay, this is exactly the result. Okay, this is exactly the result. So it's either true or false. Or you want to do other things, like for example, if more than B, so the answer is true. If it's less than B, the answer is false. Okay, and then if the answer is more or equal than B, okay, the answer is true. Less or equal than B, the answer is false. Okay, if we create all of them, 6, if we have 6 here, 2, 3, 4, 5, 6. So here we have equal. Here we have not equal. Here we have more. Here we have less. Here we have more or equal, and here you have less than equal. Okay, so you put it here together. So here on top here is false, and then we have true, true. Okay, we have false, we have true, false. Okay, this is the result. Okay, so the result is seriously is a true or false. Okay, so you don't have to argue why the result is like that. Okay, no, no, no. This is the purpose of programming. It's either true or false. Okay, so here is an example. Okay, so how exactly we you going to use this true or false, sir? Okay, like for example, kind of interfering with all of this. Okay, we have how we are going to do a program with this true and false. Sir. So basically, when we do a program using true and false, we are going to use it in if and else. Okay, if and else. So if and else is basically a condition. Like for example, okay, let me show you here. Okay, so if I put one, if A is equal B, and then we have print. Here we put something. A is similar to B, and then we have else. Okay. Print A is not similar to B. So here is one case. Okay. So when you run it, what you get is A is not similar to B. Okay, means that it skipped this one because this one is false. Okay, and this one is not false. Okay, so here because this one is false, okay, it will enter. It will skip this part and enter directly down here. Okay, so when it enter directly down here, what you get is the result from down there is A is not similar to B. This is where we have the comparison work in. Okay, so if you know, we want to ask what is the comparison used for? It's actually for us to reroute. Okay, reroute. So reroute the code. Okay, skipping one code or avoiding one code later on when you conduct your programming. Okay, so okay, so this is one example of arithmetic operation. Okay, here you have develop a program. My PowerPoint is a little bit off. Okay, so here you have develop a program based on the flowchart. The outcome is to calculate modulus from the entered number. Okay, so here you have an algorithm. Okay, algorithm provided for you. Begin, enter number in integer. Outcome is equal number modulus 2. If outcome is equal 1, okay, is true, print odd. If outcome is false, print even. Okay, so this is one of the tasks that we are going to do today. Okay, so basically, okay, what we are going to do is this short program. It's not that difficult. Okay, num is equal eval input, enter number in integer. Outcome is equal num modulus 2. Okay, this is where we want to find out whether it's a odd or even. And once it's confirmed, okay, 1. Okay, the 1 is when you have modulus, if it's an odd, usually remainder is 1. Okay, if it's even, remainder is 0. So if it's odd, okay, we'll print if outcome is equal 1, print odd, else print even. Simple like that. Okay, so if you want to do in Tony, okay, for example, here we have num equal eval input, enter a number. Okay, and then we have outcome is equal num modulus 2. And then you have if outcome equal 1, print odd, else print even. Okay, so when you want to run it, you have here enter a number down here. Okay, like for example, you enter number 5. So you get answer is odd. Okay, so you want to make it a little bit more fun. Okay, you can put okay num okay is odd. Okay, and then you put down here also same thing num is even. So this one is like last week. Okay, enter number, like for example, enter 3. 3 is odd. Okay, or you write it again. 4. Okay, 4 is even. So it's like that. Okay, so it's a simple code. Okay, you are going to go more complex programming. Okay, with a simpler code. Okay, so now next we have this trigonometric function. Okay, so in order for you to use, like for example, you are going to do a lot of trigonometric equation, something like that in your studies, everything. Okay, you can use Python as well to help you calculate a lot of things. So you need to, however, to use this function, you need to import a math module from a Python library and need to call the respective function. Okay, in the math module, okay, it's like a module. It's like a print, like for example, print or input. It's already a predefined function in Python. Okay. However, certain function is not defined previously in Python, so you need to add those function in the Python by adding by importing the module inside Python. So we have the math module is need to be imported into Python when you want to use this command. Like for example, here we have command acos, okay, arccos, and then we have arcsine, arctan, okay, arctan power of 2, okay, and then we have cosine, we have hypotenuse, and then we have sine, tangent, degrees, radians, everything. So if you want to use them, okay, it's one way. Yeah. And then we have here, like for example, when you want to import a module, okay, like for example here, import math. Okay, import math. So when you want to do import math, okay, when you want to use a function inside math, you have to use the function like this: math dot a arccos. Like for example, arccosine here, you have math.acos. Okay, acos here. So here we have anything that from module outside of Python, you need to include the module name first, dot, and also the function. Okay, the same thing for other module as well. Okay, from this, you can get the result of any trigonometric function that you want to use. Okay, so like for example, let's start with this one. Okay, so find the angle, okay, theta for the triangle. So find the angle theta for the triangle. So angle theta is here. Okay, so how do you calculate? How do you calculate? So here, let's say A is equal 5, B is equal 5. Then theta is equal, this is radian or 45 degrees. So let's try and look back, refer back. So you need to put in the module first, import, okay, math. So here you have theta is equal, you have, let's say, we put input, A is equal input, eval, input, enter side A, B is equal eval, input, enter side B, and then what? You got theta. So here you have math dot A10, okay, B divided by A. No, it's not B divided by A, let me go back. A10, I think it's B divided by A. Cosine of X. Am I right? Supposedly I'm right. If I'm wrong, you can correct me, okay? So B divided by A. Okay, so here you have, okay, print, okay, theta is, so let's check later on whether I did it correctly or not. Theta. Okay, so let's run it. Enter side A is 5, to side B is 5, and you got 0.7853981. So it looks like I'm doing it correctly. So you need to put in the units, okay, or not. Your lecturer will angry at you for writing answer without units. Okay, this is common thing. Okay, so let's run. Okay, enter side A5, enter side B5, and you got 0.785 398 radian here. Okay, so how about we convert this radian into degree? So you have at here, example here, okay, degrees x, convert angle x from radians to degree. So here you can use something like this. Okay, you can just add here, radian. Okay, let's put here. And then you have degree Oh, we need to forget the module name, math degree, theta. Okay, we'll put in. Okay, side A5, 5. Oops, I did wrong. Degrees, we have X. Okay, okay, so A5, B5, and then you got here, theta is this radian or 45 degree. So you got the answer for this equation. So it's not that difficult, right? So simple one for this exercise here. Okay. So in order for you to use math, like for the trigonometric function, you need to remember that you put the input here, the module first. And when you want to call out the function, you need to put in module dot the function name. Okay. So like this one, I use it for arc10, and here we have degrees conversion. Here we have here. Okay, so this is an example for you to use module for your equation later on. So next time, if you use any other module that you have, okay, instead of trigonometric, you have usually we have graphs module, and then we have other things like integral, what you call it, differential integral module. We have a logarithm module. So you can find out those module and refer back. Okay, you can refer more of them inside. Okay, you can refer more of them inside the tutorials point. Okay, we have a lot of module there. You can find out all those functions from there. Okay, so here we see that what we have here, begin, enter value A and B, angle equal arctan B divided by A, and then you have print angle, and then we have N. So it's simple as that. Okay, so this week class, it looks like difficult, but actually it's quite simple. The code is really, really short. Okay, so the function that you need to do here use is A10. Am I correct? Okay, A10. So it's an arctangent. So it's been a while since I used trigonometric. Okay, so since you guys are engineering students, okay, you're supposed to understand trigonometric very well. Okay, so this example, okay, you see that, okay, A is B. Okay, then we have angle A, math A10 B divided by A, and here is the result. Okay, so let's look into symbolic math. Okay, here we have SymPy. Okay, so the use of computers to manipulate mathematical equation and expression in symbolic form. Okay, math objects are represented exactly, not approximately. Okay, mathematical expression with unevaluated variables are left in symbolic form. Okay, like for example here, math is square root, for here, math dot square root 9. So here you are going to find out square root of 9. Output is 3.0 because 9 is a perfect square. But what if math square root 12? We have a 12 square root. Output is 3.46410161513775544, which is an approximate. Okay, so it's not the exact square root of 12. Okay, recall that square root of 12 is square root of 4 times 3, not 4.3, 4 times 3, which is equal to square root 3. Okay, so when you import the SymPy library, okay, that available in Python library, a full-featured computer algebra system can be used. Okay, so this one is where we are going to use algebraic manipulation, calculus, matrices. Okay, so means that you can conduct almost like your additional mathematics in your SPM in Python. Okay, even all the step is shown perfectly. Okay, so like for example here, okay, when you import some SymPy, okay, import or module SymPy, okay, simplify the code syntax. So this one is if you use SymPy import here, okay, here all the sub module, okay, you can use it directly. You don't have to use the SymPy dot here. Okay, you can import directly like for here. Okay, x is equal symbol x. So x symbol here is a part of SymPy, but you don't need to put in SymPy dot symbol or something like that. Then you have expression integrate here, and then you have expression here result, and here you have x equals 7, and then here you have x equals 7, and you have to produce square root x, float, this, rational number, 3, this, irrational number, 0.2. Okay, so here, okay, the result, okay, looks like here, let's generate in Tony, so in case you can get clear view. Okay, so here we have SymPy, import SymPy. So from SymPy, import, okay, pointers here. And you have print Like for example here, SymPy. Put it up here. So we start with this one first. Okay, when you generate this one, oh, okay. So when you generate this one, what no module name SymPy? Supposedly got that. Oh, thank you. Ada tegur saya salah aja SymPy. SymPy here. So I did not install SymPy. I think I got SymPy. No module name SymPy. I think I need to import SymPy. So let's try square root 12 supposedly. Supposedly I need to import SymPy. I'm not sure whether SymPy is still available or not. Or is it my spelling is wrong? Let's take a look. Okay, I forgot to install this one. Okay, supposedly your Tony. Okay, let's do it again. Okay, if you cannot use it, means that it's not installed. The packages is not installed in your Tony. So you just okay, tools, okay, manage package, and then you search for SymPy. Okay, you found it, SymPy, and then install. And when you want to install, it goes just like this. Okay, so good thing also I didn't install so that you guys notice this kind of problem, you guys can look at the video and do it the same thing. So might be a little bit long. So just wait for a few moments. Okay, while we finish. Okay, close. So let's try again. Or do I need to restart the? Oh no, I don't need. So you see here when I use SymPy, okay, SymPy dot square root 12, I got 2 times square root 3. Okay, 2 times square root 3. So this is one of SymPy benefit lah. So you have from, okay, let's compare it with original one. Original one for Python, for square root we have, like for example square root 12, we have 12, okay, over 1 half. No, it's a negative 1, I think. Yes, power of 1, negative 1. So let's take a look. Wait, is it correct? Square root 2 negative 2 power of negative 1 is square root of 2, I guess. Okay, so you get the result like this. You have different of here. So you have, like for example, let's try. Is it correct? Oh, wrong. So mine is wrong. So 1 square root negative 1 is, because square root is 1 over 2, I think. Yes. So correct. Okay, so here we have two types of answer here. Okay, this one we're not using a SymPy library. This one we're using the SymPy library. So 9 is a square root of 3. Okay, precise 3. Okay, you see that the using SymPy and the original Python version, okay, it doesn't make much difference. But if you use a square root that is not an exact square root, like for example 12. Okay, you see that the result here is 2 times square root of 3. And then here the result is 3.466 blah 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 blah. Okay, so this one is one of the benefit of using SymPy. You can understand the equation step clearly here. Okay, so from here again we have from SymPy we have integral. Okay, so express integrate x power of x. Okay, so you get this you get the expression is as here. Okay, so this is a part of the equation as well. Okay, you can see clearly here. So you have float also. If you want to see, like for example, you have this value 133, okay, exponential 5. You want to see the whole value. Okay, you can put in float 1.33 E5. You can get the full value. And here for rational number 3 out of 4, and for here a rational number of 0.2. Here you get this one, and then all of them is generated using the module of SymPy. Okay, let's go towards here first. Okay, using the SymPy. So we have here a rational number. Okay, so here you have So you don't want to use SymPy command in your codes, you can just import a is equal rational 1 2. Okay, so we get the result, print a. So here we get the result, okay, 1 over 2. Okay, this is one of the result, 1 over 2. So let's go towards more. Okay, so symbol here, okay, we have xy, symbols xy, express x plus 2 times y. Okay, the print expression. Okay, and here expression plus 1, expression minus x, x time expression. So this one is quite useful. Okay, in case you want to use mathematics, you want to do a mathematics algebra equation, and even okay, if you have brothers or sisters in high school who want to check their mathematics answer, you can introduce them this. So here, like for example, you have x, y. Okay, symbols x, y, and then you have expression equal x plus 2 times y, and you have print xpr. Okay, so from here, let's start this one first. So you can see here in my code here. Okay, so what I did is I want to express this equation here. Okay, so I got here x plus 2 times y. Okay, here. So and then I want to edit the equation. So print xpr plus 1. Okay, and what you get here, let's put all of them as one. xpr minus x, and here you have print x times xpr, and you got the result here. Okay, for plus 1, you get down here x plus 2 times y plus 1, and then you have 2 times y here. Okay, x because you deduct with minus x, you got 2 times y, and here you got x times x plus 2 times y. Okay, so you calculate the algebraic equation immediately for you to understand. Okay, so it's really quite useful. Okay, so other than that, you have, okay, like for example, you want to make integral. Okay, you want to make integral. Okay, derivation, differential and integral. So this one is derivative from sine x exponential x. So you got here differential sine x, okay, times exponential x. Okay, and then you have this is x. Okay, you want to differentiate this. Okay, and then you have here integrate exponential this. Okay, this is the equation, and then you have this is. Okay, you can try this in your Tony right now. Okay, what is the result for that? Okay, you can try it first. Okay, we can try it together. So start with import SymPy. Okay, if you don't want to use the word SymPy module, SymPy dot before the function, okay, you can use this from SymPy import. Okay, so you try to do this one first. X is equal symbol x. Okay, now we're going to do print differential sine x. Okay, there you got x. Okay, so let's start with this one first. So let's see what kind of equation it generates. Okay, oh, this one. Okay, you see that the result is exponential x times sine x plus exponential x times cos x. So this is the result. Simple, right? You have here to differentiate sine x times exponential x with x. Okay, so this differential x. Differential x means here. Okay, this is x means dx. Okay, so okay, so please try for the other two here down here. So let's try second one. Print integrate exponential x times sine x plus exponential x times cos x. Okay, so let's take a look at next one. Okay, this is the second one. Okay, so you see that the result for the next one is integrate this. You got exponential x times sine x. Okay, so next one is we try next one. Print integrate sine x. Okay, you have minus infinity to infinity. Okay, so we have this one. I think I got short. Okay, so when you run the third one, what you got, the result you get is, oh, x is not defined, dash x. Okay, so you got square root of 2 times square root pi divided by 2. This is the result. Okay, it's very simple, right? Easy for you to do. So it's not complex things. It's just to make your life easier. Just the command here is integrate, okay, differentiate, integrate, and then you have exponent, and then you have sine. So this is based on your mathematical equation from here. So Python really helps you to create calculation easily. Okay. So I'm still wondering, why didn't they make scientific calculator using Python yet? I think there are some example, some apps for your smartphone, okay, for you to write Python in and generate the result. Okay, your smartphone can be a better scientific calculator with this. Okay, so this is one way for you to do. So then we have algebraic manipulation. Okay, so this one, if you have brothers or sister in form 1, form 2, form 3, okay, you can introduce them this. They really like it. Okay, they can even cheat in their exam, something like that. Okay, so here we have x is equal xy, symbol xy. A is equal expand xy power of 3. Okay, so this is the equation that the problem is. Okay, you want to expand it. Okay, when you expand it, what will happen here? Okay, let's use the same code before. Okay, we have xy equal symbols x, y. And then a is equal expand x plus y power of 3. You have print a. So in this case, what you get is, oh, supposedly large, I think large. Oh, forgot. This is one way. Forgot import SymPy. And from SymPy, import all. Oops, supposed to be symbols. Okay. So here we have this equation, x power of 3, 3 times x power of 2 times y, then 3 times x power times y power of 2, and then you have y power of 3. Okay, so you get the result here. Okay, so this one example. And for example, this one for expanding. And next we have simplify. So here you have x plus x times y divided by x. Okay, so same thing, if you want to simplify, so we put another one down here. Okay, a is equal simplify x plus x times y, okay, divided by x. Okay, and then we print a. So when you run this, simplify or simplify. Okay, so you got this. The answer is y plus 1. Okay, this one we comment out first. Okay, So you got the answer is, oh, this one need. Okay, you got the answer is y plus 1. So a simple one here for algebraic equation. So expanding and simplifying make things easier lah, for equation, especially if you want to do it to run your homeworks or everything. Okay, so for SymPy packages, you can refer to the SciPy lectures. Okay, for packages for SymPy, here you can refer to the website later on by yourself. Okay, to discover more potential for you to use them in your studies later on. So now let's start with exercise. SymPy as a calculator. You can use this SymPy, okay, to calculate this one first. Okay, so for rational number arithmetic and also for uh, percent 2, no, root 2. So don't forget to use SymPy here. Okay, so you can put in a equals square root 2, and then you have b equal rational. I forgot also. So let's refer back to rational number. Okay, so here rational 1, 2 is 1 over 2. 1, 2 plus rational 1, 3. Okay, let's look up print A, print B. Okay, let's try again. The result is rational is not defined. So this one rational is supposed to be in math or SymPy. Forgot. Or let's. I rarely use this module, so I often forgot the command. Okay. So you got here for rational. Okay, rational means that you want the answer is not in floating number. Okay, 3.45657 something like that. Okay, you want the answer is in equation, in like for example in fraction number as well. So here you have 5 over 6. Okay, for square root 2, here you got the answer is square root 2. Okay, this is not a comma, this is the answer. Okay, square root 2. Okay, so if you want to calculate it even further for with 100 decimals, okay, so in this case you can use, I think you can use float. No. How exactly for you to calculate in 100 decimal? Need to refer back. Okay, so square root x. The answer here is supposedly can. Let's try again. A square root. Mm, let's try like this. Is there any different? I don't think there will be any different. No. So let's try for 100 decimal. Usually we don't use this one, we just use this one. 2, 1 over 2. Okay, so this is one way for you to do it, but in case you want to do it further around a 100. I think it's limited to here. So the question kind of like wrong. I think I will change it later on. Okay. So try and do this first. Okay. So this one supposedly the answer just square root a, square root 2. Okay. Okay. Supposedly this is the answer that he wants. Okay. So the question wants. So this is correct one. Okay. So it's not that difficult. You guys can refer it again. You can refer to this video many times later on. Okay. So next, okay, let's try for this algebraic equation. Calculate the expanded form for xy. Okay, so let's try and do this one. Xy is equal symbol x. I also forgot the command. Okay, symbols xy. So something like that. Symbols x, y. So next we will do the form. Okay, like for here we use xpr is equal uh, x plus y. Okay, power of 6. Then print xpr. So you get the result here. Okay, the first one. So next one for the second one, simplify. Here is the first one is the equation first. You need to expand it. Okay, how do you expand it? Okay, just put expand. Okay, let's make a new one. I think you can use this command. So this is the expansion result. Okay, if you want to do something like mathematics, you can do it something like this. Okay, expr equal something like this. Okay, x plus y power of 6 is equal x power of 6 blah 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 blah. This one is the answer. Okay, so it's simple one, simple case for you to do for your exercise. Okay, so do you have any questions so far? Do you have any questions so far? No question? No question? Ada soalan? No, okay. Okay, so let's go to another exercise. Okay. Next one is please you do the number 2. Simplify the trigonometric expression sin x divided by cos x. So I'm going to take a few moment breaks, 2-minute breaks right now. Okay, please do it now for the exercise. Download SimPies is easy. Okay, you go towards Tony here, tools, manage package. Okay, and then you just you got this window and search for SimPy. Okay, so you search for SimPy, you got SimPy here, and then you guys just install. I already installed, so I have the uninstall command. So if you haven't installed, you got install here. So install it now. So download directly from Tony. No need to go towards any website. So please do the number 2 right now. I need to take a break for a moment. Can or not? Can or not? Hello? Can you guys do the second one or not? Okay. For the second one here, okay, same thing. Okay, you have one equation here, which is sine x divided by cos x. And you have down here uh, expr is equal simplify expr2. Simplify expr. So when you're done, you see that the answer is Sin x divided by cos x is equal tan x. Okay, this is the simplification. Simple one, right? Not that difficult. So uh, should be fast when you do it. Okay, so the program in Python is to help you simplify a lot of equation for your mathematics. So it's good to use them. Okay, it's really helpful if you know how to use it. Okay, so here is the answer. Simple one. A is equal to simplify sin x divided by cos x. You can also do it like this. Okay, so you get the answer here. Okay, expansion here on the top, and you have this 10x as the answer for number 2. Okay, so finish with SimPy, and next we go towards binary operator. Okay, so for binary operator, it might be quite difficult for you guys since you guys are not familiar with binary. Maybe because of your this binary. Usually we teach them in computer science. So as usual, okay, for we have logic gate, we have AND gate, OR gate, XOR gate. So this is common gate that we have. And for example, for AND gate, okay, AND gate is when the input is 1 and here is 1, okay, the answer is 1. If the input is 1 and another input is 0, the answer is always 0. Okay, and OR is if one of the input is 1, okay, all of them will be 1. If one of them is 0, if both of them are 0, the output is 0. Okay, and XOR is, okay, output of the logic is 1 when only one of its input of the logic is 1. Okay, otherwise it's 0. If it's the same, like for example 0 0 becomes 0, okay, 1 1 becomes 0, okay, 0 1 and 1 0 it becomes 1. So this is XOR. So this one is for us to calculate binary. Like for example, A is equal 60. Okay, in binary A is 0 0 1 1 1 1 0 0. Okay, B is, okay, like for example 13 is 0 0 0 0 1 1 0 1. This is our calculation. You need to, how you get this? You need to convert them by yourself lah. Okay, how you get the binary. And then we have here binary operator. We have n. N means 0 0 0 0 means that it combines. Like for example, 0 0 1 1 1 1 0 0 0 0 0 0 1 1 0 1 here. Okay, for n means that in case it's a 1, it become 1. Okay, in case it's a 0, it becomes 0. In case it's 0 or 1, it become 0. So like for example here, n means times. 0 times 1, 0. 0 times 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 0, 0. 1 times 0, 0. 0 times 0, 0. 0 times 0, 0. So this is the result for A and B. So this is the result. So in binary, what is it? What is it? So if anybody good in binary can guess what is the answer? Nobody? Nobody can guess? Anybody can guess what is the answer? Here. 60 and 30, 13 in binary n, the answer is 12. The answer is 12. Okay, so 13 is 0, 0, 0, 0, 1, 1, 0, 1. 12 is one shot, 1, 1, 0, 0. This is 12. Okay, don't worry how do I calculate it because I'm really used to binary because we are in computer science, we need to use it binary. So an OR. OR is where you have calculation for more like plus. Okay, 0 plus 1 is 1, 0 plus 0 is 0. Okay, 0. 1 plus 1 is 1, 1 plus 1 is 1. We don't have 2 in binary. Okay, so if it's OR, 1 plus 1 become 1. Okay, 1 plus 1 become 1. And then here 1 plus 0 become 1, 1 plus 0 become 1, 0 plus 0 is 0, 0 plus 0 is 0 here. So this is the answer. Okay, for all. 0 plus 0. Yeah, here, 61. Okay, the answer here, if A or B, the answer is 61. Okay, and now X is XOR. Okay, XOR. So here you have 60 XOR 13. Okay, what will be your answer here? Okay, XOR is when 1 and 1 will become 0. Okay, or 1 and 1 become 1, right? There is no 2, become 1. Here 1 and 1 become 0. So almost similar to OR. Okay, you see that the result here for 1 and 1 is become 0. Okay, and then we have binary ones complement. So binary ones complement is where we convert uh, a real number into a negative number. Okay, like for example, okay, so 60, okay, if you convert it into 1 complement, it becomes 61. Okay, 61 minus 61. It will add another one. Okay, because why? 0 for complements, we have two zero, positive 0 and negative 0. So that's why it become additionally plus 1, negative 61. Okay, so this is why we have negative 61 here. And then we have binary shift. So what is binary shift? Okay, let's look at A here. Okay, it goes left. Just refer it to me. I refer it as left, left 2 times. Left 2 times. Means that all of this will go left 2 times. Left. Okay, remove this 0. This one will go left 1 times. And then it will go 2 times. So this one, 1, 1, 1, 1 here. Okay, go left 2 times. 0 on the front, go back. Okay, it's shifter. It shift to the left 2 times. Okay, and then we have here right 2 times. So here you see that this is the result. The 1, 1, 1 go towards right, and the 0 at the back go towards the front. So this is means that it goes to the right side 2 times. So this is where we have left shift and right shift. Okay, so you see that. Okay, when we do this, you can see the result here. Let's try and do 1. So you have A, B, C. A is equal 60, B is equal 13, C is equal 0. So let's do C. Let's go directly print. Print C is equal A and B. Okay, let's see what is the result here. C is not a valid keyword. Keyword argument for one. Let's just remove this one. A and B. So you got 12. So how you got 12 here is because of the binary that I mentioned before. A and B will become 12. And then here next we have print A or B. Or B. And then you have print A X or B. And then you have print complement A. And you have print A shift 2 times left. And you have print A shift 2 times right. So you get the result here. 12, 61, 49, negative 61, 240, and 15. So this is a binary calculation, okay, using logic gates. Okay, so this is one way. So if just for you to know, okay, you don't need to understand, I don't know about binary, so okay, never learn about binary, everything. You just need to know that this is one of the operations that we use to convert the binary operation. Hopefully, it will not enter the final exam lah. Okay. Okay, so this is the result, same thing. So all of this is available in the Python tutorial, a tutorial spawn. Okay, you have a lot of example online. I provide in the slide. You can go and refer it in your own computer later on. Okay, so it's 33. Okay, we have a lot of exercise. We have around 45 minutes yet left. Okay, let's start by doing an easy level exercise first. Okay, so you guys start with doing this one now. I'll give you around 5 minutes for you to complete them. Okay, starting now. Easy level exercise. Okay. Okay, you can do them in Tony by yourself. If you have any question, you can ask me. You guys can do it or not? Simple one. Ada problem ke? Can. Okay. Easy. Okay. So this one is for integral. Okay, let's do it in Tony together. Okay, import math from SymPy. Actually, this has been a while since I code using packages in Python. So I eventually mistaken some of the commands, everything. So it's not like I cannot do it. It's just uh, Okay, it's like if you spend a lot of time with other things, you get confused with a lot of things. So this is one of the things that I get confused sometimes. So it's not the only programming language that I've been doing right now. Okay, so if you deal with a lot of programming language, okay, you get confused eventually. Okay, so I've been reading Java, I've been reading JavaScript, I've been reading C, and sometimes I got mixed up all of those commands. Okay. Okay, so here is one way. Okay, invalid syntax. Okay, let's put some space here. Okay, x is not defined. Where is x? Integrate x is not defined. So, oh, so supposedly x is equal symbols x. You guys can do it because I got error. There must be something wrong. Why is not defined? Oh, why also I did not define? Why? How come you guys can do it when I cannot? Uh, so now I can get it. Okay, so this is define. Okay, so define can. Okay, so okay, need to define wine. So correct. You guys are correct. Okay, so here we have integral, and then you have this one is for expansion. Okay, so this is the result. Easy level. So let's go towards the answer here. Okay, so simple case. Okay, um, this is one of the exercise using math. Run the code below and fix the code, and this is the output. Okay, so try and run the code and fix the code here. And where is the problem exactly? So this is an easy level exercise. Okay, we have medium level and also hard level. So please do it as soon as possible. Okay, how is it? Guys can do it or not? Okay, let's try do it. Input my math by B the area of parallelogram. Okay, is area parallelogram. Okay, so because I'm lazy, I am going to copy paste everything. So this one, I copy paste it 4 times. Okay, programming is copy pasting. So don't worry. Okay, 1, 2, 3. Okay. So here then we change it this one into square. And this one also I'm going to copy paste. Too lazy, too lazy. Okay, the equation change b times 2. Is it correct? Area square b times 2. Hmm. Okay, and then we have area of circle. Copy paste again. So here is pi r power of 2. And we have last one is kun. Kun. So change copy. And another kun. So equation is 1.0 divided by 3.0. 3 times pi times r times 2 times h. Okay, so let's try run this one. What happened? Is it correct? 28, 1960. The output should be here. So this is wrong. Means that the equation is wrong. This is supposed to be power of 2, right? B power of 2. Okay, this is also power of 2. Okay, this is power of 2 times h. Okay, so you get the answer here is correct. So this is the difference between times and power. Okay, so any question for this one? No question. No question. Okay, no question. Then we have a second one. This one is immediate level. Develop a program for the following computational problems by using function in math and SymPy module. If needed, your program must request user to enter the value. Calculate how much money, expected money in a bank that a user will have after certain years with certain percent interest rate. Let an initial money in the bank is A, bank interest rate is P, and N is years. So this is the equation, the algorithm. Okay, your task is to develop the program. You can start now. Okay, imagine this is your hand-on test. Supposedly this is a hand-on test level actually. A little bit difficult. Hand-on test might be a little bit difficult because you have things that you haven't been introduced yet. Okay, almost like a hand-on test. Actually, this one is what we given to diploma student before. Okay. So this is the algorithm. Okay, try and do the code by yourself. Okay, I'll give you 5 minutes to do it. Okay, so let's try and do it here first. Okay, we have this one, intermediate level, another one. That's later on. Okay, so this one is simple. You download SymPy. Irfan, why my Tony always error? Okay, you want to share your screen or what? Share your screen here. Let's see what is the cause of error. Your computer or Tony or you? Okay, so let's share your screen. Irfan?
Okay, sekejap. Datang.
Okay, we can reserve the hard one for your lab session lah.
This tu. Nampak tak?
Okay. Import SymPy itu salah tu. Bukan import
SymPy.
Import
SymPy. Tambah lagi satu kan?
Import SymPy je cukup. Pakai SymPy.
SymPy.
Okay dah, cukup run.
Yeah. Still.
Okay. SQRT. Mana yang square root ni yang awak pakai?
Tak tahu, tak ada pun. Ini je.
Cuba tengok yang yang tadi tu.
Ya. Alright, mana?
Yang belah kiri tu exercise SymPy.py tu tutup dulu.
Tutup dulu. Okay.
Yang dua ni kan. Okay. Okay, cuba run.
Still error.
Ada kat mana kau letak square root ni? Mana square root?
I don't know. Tak ada pun. Saya dah refresh balik pun still tak dapat.
Cuba lebarkan sikit skrin tu. No attributes, square root. Ada kat bawah ada print SymPy square root 12 tu. Ada kat mana saya letak? Mesti ada kat bawah.
Before, tak kat mana? Kat bawah mana?
Tak, sebab ada command tu kan. Print SymPy square root 12 tu. Dekat mana awak letak?
Before yang saya download tu, saya ada try dan tak boleh. Dan lepas tu saya download, dia jadi macam ni je. Ke sebab tu?
Kena cuba tutup dulu and then buka balik.
Kejap.
Tutup Tony dulu, buka balik. Tutup dulu. Tutup. Close all. File. Buka file. Dekat tadi file. File. Close all.
Right.
Okay, cuba type balik. Open ke apa? Open balik tadi. File tadi pun tak apa. Open file tadi pun tak apa. Tadi awak ada simpan file kan?
Mana aja? Ni, simpan.
Okay, open.
Right.
Okay, so run balik.
Sama je. Maksud.
Desktop simpai.py line 2. Ada dekat desktop awak tu, simpai.py tu yang mana?
Desktop. Simpan.py don't know. Tak ada pun.
Tu belah kiri tu. Delete.
Ni okay. Delete. Delete ni lah. Delete habis lah.
Delete sampai habis tu. Buang.
Sekejap.
Okay, cuba run balik.
Dan try again.
Okay. Okay, mana problem tadi tu sebab dia ingat yang tu library awak tu. Sekejap, saya tak nampak.
Okay.
Integrate XSSI. Betul ke eja dia? Integrate saya rasa eja dia lain. Sekejap.
Integrate macam mana je, dah lupa dah. Sekejap.
Dia tak ada R, bukan integrate, dia integrate.
Integrate, lupa, tak silap.
Okay.
What? Tak ada ni. Alright, okay.
Lambat je. Okay.
Alright.
Okay, so that's all lah. So make sure you save the name, jangan nama sama dengan nama library. Okay, jangan nama sama dengan modul. So they will have a problem there lah. Okay.
Kalau ada satu salah tu memang kena delete terus lah.
Dia miss that saya suruh delete tu sebab the computer confuse the Python library dengan you punya ni. You punya code. Okay, so dia ambil you punya code tu sebab dia ingat library you.
Okay, thank you Dr.
Okay. So this is how sensitive lah. Okay, so ada questions? Okay, ada questions? Tak ada. Okay, so let's try and do this one. So we'll reserve, this is the last example lah before we go in. So we have 3 values. Okay, so let's start with A. Import first lah. Import. Simpai. I think you can just go directly here from Simpai. Okay, import. Okay, then you have A is equal eval input. Okay, insert A. And then you have P is equal eval input insert P. And then you have N is equal eval input insert N. Okay, so here we have 3 inputs. From these 3 inputs, we go towards the equation immediately. Expected money. I put it EM lah. M is equal A 1 plus P, okay, divided 100 power of N. So A is times times 1 plus P ni you kena make bracket. Supposedly no, there's no need to make bracket. 1 plus P divided 100 N. Okay, supposedly power M. Okay, so here we go directly. No need to use simpai actually. Okay, print EM. Okay, so let's try. Run it. Insert P. All of them need. Gosh, forgot one. Okay. So A is. Do we have any sample answer? No. Okay. So you say A is equal. A is what? A is initial money in bank. Let's put it 100. Okay. P is interest rate. 2. Okay, and then we have N is years, 10. So at the end, expected money that you get, okay, after 10 years, okay, is 121.89. So here you can make it round lah. E underscore M 2. Okay. No need to use simple, right? If needed. No needed lah. Okay, so you can get it immediately as well. Okay, 2%. And you have 10. Yes. Okay, 121, 9. Okay. So, okay, any question for this one? So before we end, I would like to introduce you the answer for last week, and also we need to take attendance. So I think we have this intermediate level and also the hard level. I will put it inside your lab sheet. Okay, later on. Okay, so before we end, okay, I would like to open the lab sheet for last week. Okay, so last week for programming, the lab sheet for last week. Okay, I'll take a sample example from your friend, sample answer from your friend. I think I just take this one, randomly open. Nur Azlina, okay. I think she's from another section. Okay, or this section, I'm not sure. Okay, so here you have, okay, you have the equation for last week. Below is the quadratic formula. Okay, so let's see the result from this one, Nur Azlina result. So I like using Google Form because it's easy for me to download and use the data here. Oh, what's wrong here? Okay, no problem. Supposedly no problem. Okay, so value of A is, let's take a value of A is 4, 5, 2, 6, 3. Okay, solution are this. Wow. Okay, so anybody can get me an example. Okay, so this is also working. So it should have no problem. B, okay, D is, what is D? D is B power of 2 minus 4 AC. Oh, she created the D first. Okay, good. So minus B divided by 2A. D times D power of 0.5. Good. This is root 2. Okay. So this one is good. So means that the result is correct lah. Okay, no problem in the equation for question 1. Okay, thank you for Nur Azlina for the answer. So let's take a look. Random person number 2 is Amelia Azri. Let's take a look. Okay, so here we got from Amelia Azri. Okay, I think the question number 1 here is not correct. Okay, let's try and run it. It's not correct. Okay, looking at it also it's not correct. Okay, she didn't do it in Python properly. Okay, so this one is wrong, basically. Syntax error. What the hell is this? So this one is wrong. Okay, supposedly she need to do it like what Azlina did before. Okay, she need to do it according to this one. So comparing Azlina and also siapa ni? Amalia. Okay, so what Amalia did is here, down here. Okay, let's separate it to two. Okay, you see the difference is between these two is that, okay, the equation part. So this one, Azlina, she did with the correct format lah. So this is power of 2. Okay, so there's nothing here shown as power or square root here lah. So it's wrong. And then the multiplication is also conducted wrongly. So you see the multiplication here. Okay, and then here is the correct multiplication. So you need to make sure that you have the correct value here. Okay, and the result also, if possible, show it properly lah. So this one is very simple lah, so it's quite wrong. Okay, so we go towards number 2 question. Okay, using the formula below, okay, create a program to calculate the travel time between, okay, based on the distance travel displacement in kilometer and velocity can be put by the user. Okay, I want you to calculate the travel time. Okay, so this one is from Amalia. So let's take a look at the answer here. Amalia answer is, okay, enter D. Let's take a look. Kilometer. So 200 kilometer. Okay, with 100 velocity. Okay. Kenapa kena ada enter time pula? Because I want to calculate time. So this one is already wrong. Okay, so she asked everything. This is wrong. Okay, this is wrong. Okay, so this Amalia person is doing it wrongly. So let's take a look at random person number 3. Okay, Ashraf Azman. So let's take a look at his equation. Also, I think okay, good. Okay, let's try. Let's take a look. Okay, this is Ashraf. Okay, so let's run it. Enter distance 200. Enter the velocity 100, and you got the travel time 2 hours. Okay, so this one is a correct one lah. Okay, so travel time based on the distance. So here is 200, 100, and then you got it 2 hours. So this is a correct one lah. So if for example I put in 230, I want to I got 1.92 hours. Okay, so if he's really good, he convert the 92 to minutes lah. Okay, so this is the better one lah. Okay, so this is one example from Ashraf. I think so, Ashraf Azman. Okay, so if you have any good example from others, so let's go random person number 4. Super Solihin. Oh, looks like good, awesome, powerful guy lah. So this guy function to calculate distance, calculate velocity, calculate distance. Oh, he did all of them 3. Okay, calculate distance based, calculate velocity based on distance and time. Calculate distance based on velocity and time. Calculate time based on distance and velocity. Oh, he did all 3. Oh, he really likes Python. Okay. Question number 1 also really well lah. Done. Who is this super Solihin? Definitely super lah. Okay. So next, we go towards number 3. Question number 3 here. Okay, using the equation below, develop a program to calculate the volume of a pyramid based on the side and height of the entered by the user. Copy your codes from Tony and paste it as the answer of this question. So this one, okay, see the answer here. Okay, and let's take a look from Super Solihin here. And then we have the answer. Enter the value of A is 2. Enter value of H is 3. And the value of V is equal 4. Okay, so it's a simple exercise here. Supposedly, okay, you can do the answer here. Okay, according to the sample that your friend provided. Okay, a good one and also the bad one. Okay, I hope from the bad one you learn to not repeat those mistakes, and from the good one you can learn to create as good as them. Okay, so this is the exercise for last week. Okay, so for this week also we will have another exercise. Okay, based on the unfinished exercise that we have today from within the class. Okay, so before we end our class, okay, I'll open for a question and I want to take your attendance. Okay, so do you have any question? You can ask me now. Okay, do you have any questions so far? Any questions so far?
Tak ada.
Tak ada. Okay, ni okay boleh buat ah.
Ada agak yang pening tapi boleh manage lagi.
Boleh. Okay, so if actually for you guys to get pro, you need to exercise a lot lah. Okay, so programming is like playing instrument lah. The better, the more you play, the better you get. Okay, so kalau siapa-siapa yang suka main gitar ke apa ke, so you want to get better, you play a lot of guitar, right? So same thing for programming as well. Okay, you need to exercise a lot lah. Okay, practice a lot. Okay, so all of you are here. So we close our session for today. I see you guys next week during Ramadan, first Ramadan class. Okay, don't forget to wake up at 8 o'clock in the morning after your morning sahur. And for this week, we will have lab exercise again. Okay, I'll put in Google form, so easy for me to check. Okay, so for example here, okay, this is a Google form answer for your lab exercise. Okay, I can see all of your answer here, good and bad. Okay, okay, so all of your answer is here. I can see. Okay, if you want me to share them, also can. Okay, but I'm afraid that some of you might be. So don't share lah my answer. My answer is stupid. Okay, don't share my answer. I'm afraid there might be some of you like that. Okay, so please, okay, submit them in Google Form. I will make it like this one as well. I think you guys prefer Google Form than what you call it, PowerPoint, right?
Yes, Doctor.
Easier, right? To copy paste. Okay. I'll see you guys next week then. Okay, inshallah. Thank you very much for coming. And don't forget to like and subscribe my channel again. Okay, so see you guys next week later on. Okay, bye-bye. Assalamualaikum.
Waalaikumsalam. Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, sir.
Thank you, Doctor.
Okay, welcome.
Yeah, thank you, brother.
Okay.